really going to be a look at what we've actually achieved as part of this project so far with the Landcare Group. We're going to discuss a couple of case studies and what people have used their drone data for initially. And then I was going to touch on another project that we're concurrently doing down at the branch, where we've got 8 large farms which had a significant amount of money invested in them a couple of years ago to fence off wetland areas, mainly mangroves and salt marsh. And out of that, there's been some very interesting outcomes, which I think you'd all be happy with. And again, just as an example for what we use the drone data for. So we started this back in October last year, and it was part of funding that was awarded to the Landcare Group. And what that enabled us to do was buy a drone. It was a little bit laborious getting one in the end because of COVID and distributions, and they didn't have the one we wanted and a whole heap of other things. But we finally got one. And so between October and April this year, we've managed to survey just over 2,100 hectares, which is quite a large area of land to do with something as tiny as what we've got. So just that in itself sort of tells me that the capability of just the little device that we've got. We have only got 3 batteries for the Phantom at the moment, so if we got another 3, you'd pretty much be able to do a property up to maybe 100 hectares. Most of the properties I did, well, the smallest one I did was about 3 hectares. The largest one was pushing close to 300, and there were certain limitations on the days with weather and wind and cloud and rain and a whole lots of other things, and I'll talk about that as we go through. After I did all the drone work, the files that we got are actually quite large. They can be in the gigabyte sort of range, so they're not an email-friendly file to send around. But what I did do was export them into Google Earth and then save them back out as a .kmz file. So everybody should at least have a .kmz file which will give you the ortho mosaic, which is just really the aerial map, and one which had contours as well. So that'll be showing you the slope of the lay of the land. A few other people, there was an extra $50 to get rainfall and drainage calculated, and that's through Drone Deploy, and I'll get in touch on that a little bit later in this presentation. Every image that I've got is sit there and stored in Drone Deploy, and we also have a backup copy on a big hard drive which will be in the hands of Dale and Joelle at some stage in the near future. And what that allows us to do is to go back into Drone Deploy. After today, you might say, oh geez, I really like that digital terrain model. And so instead of having contours, you've got this fancy series of colours which sort of go from red high to blue low, and they're actually very visually appealing. And again, they probably look good up on the wall as well. On the left's the ortho mosaic, and the one on the right's the contours. And so you can see that you can open those in Google. They're quite small files. If you're familiar with Google Earth, you can go in and you can actually annotate there as well. So you can draw lines and boxes and things like that. So it's a very good first stage. I use a program called QGIS, which is a free mapping software, GIS software, that you can download. And it works on the principle of creating a layer, and then you keep creating another layer on top of that. It might be fence lines, it might be sensitive property grazing areas and these sorts of things. The one on the left there is the digital terrain model. So that's effectively the contours, but just looks a bit fancier. Again, you can't tap on that to get an elevation, whereas the contours in Google Earth, you can click on a contour and it'll tell you the elevation at that time. The one on the right is the Normalised Distribution Vegetation Index, and again we're still experimenting with this one, and I'll show some examples on some sites when we go into Drone Deploy later. But what this is using is red, green, near infrared and blue filters in different orders. And what it's looking at is reflectance, or the amount of green, depending on the way the filters are arranged. And I'll use a good example later on with the mangrove and salt marsh areas. Sorry, I was a bit slow on the second computer. Now, the output that people haven't got yet is the 3D model. So it comes up with this point cloud type 3D model. You have to have some pretty heavy duty software to run these sorts of things outside of drone deploy. But again, this is the sort of data that if you were bringing in an expensive landscaper consultant to do something on your property, he would love to have something like this because he could plug it in and then create conceptualizations of what you're planning, and so it makes it a little bit easier to do these sorts of things. And keeping in mind that you'll pay a lot for this data as part of if you're getting a consultant to come out and do something on the property. These are the additional applications within Drone Deploy, and what we can see here is this is a relatively flat site, but from the contour of the digital terrain model, it can look at the landscape, take a design rainfall event, which might be a 1 in 10 year event, and then it'll predict where the water's going to flow and where it's going to pool and at what rate it's going to flow there and what depth it's going to be there. And this is quite important for this site because, this is at the branch up in Gunjula Drive, sort of to the north of the branch, and it is quite flat. And when the grass is growing, you can't see any real major highs or lows in the landscape. So it makes it hard to visually think, well, do I just get the excavator and dig a drain down here? With data like this, you can actually pick and choose or exactly where you'd like to be and where your natural drainage points are already, which is... Yep.
There was still water sheeting down the back hill.
Yep. It would. I mean, but this is just like a snapshot. So, I mean, I'm more of like continuous modelling when it comes to the water runoff, but I thought for $50, it's a pretty straightforward approach that you can get from the data that we've already got. And again, that's for a 1 in 10 year event. If you ask them to do a 1 in 20 year event, you'll find that most of that will expand out and just become faster and deeper. If that makes sense.
So that's going to be really good if you're trying to maybe
Yeah, dam placement.
how your existing dams are going to cope.
Yeah. Well, I mean, if that's a site which didn't have fences on it and you were planning to have some livestock, you wanted to put in 2 dam points. What that allows you to do is you can actually see the perimeter and the area of the dam that would be there for that event. And then you could, once that's, you can annotate around and work out the surface area or the perimeter line, which is the length of fencing that you'll need to fence off that dam if you want to, and this will make a lot more sense when I talk about this project a little bit later. But from the maps you can effectively work out everything that you need and what you'll have if you go down a certain path. So if you're going to build a dam here, obviously that big purple patch, right, no, that's not going to work till there. There's a purple patch in the middle, down the bottom there, that would be where you'd probably build your dam, and there's a drainage coming in from right to left there as well. And if you wanted to make that dam, as I said, you can then work out how much fence you need, and then how much fence line you might, the design of your paddocks, what shape you want them to be. They don't all have to be rectangles. Well, it's a bit hard on this, but each one of those little dots is actually an arrow. So it's hard to see without, because the resolution's not that good up on the screen, but they're actually arrows that actually point where the water's going to be moving across that surface. So each of those little dots is actually an arrow pointing in a certain direction.
You could also indicate whatever drainage systems you've got on the property, whether it's legal or not legal.
Well, yeah, if Rod Zamanek was here, he'd be talking about the 30% that you can now take, you're entitled to, and these sorts of things. So, again, that's exactly what you can do. So if you're allowed to take a certain water entitlement through runoff, you can design a dam to be exactly like that in the spot where it is most likely going to fill up most. and stay full the most. Now here's one of the drone sites we did just south of Bulladella, and again, a lot of these. This is what, you know, when you own a property like this, you have to understand and accept the limitations. You know, some people have very high mountainous, steep cliffs with rocky ridges. You know, you're not going to be putting cattle up there or growing anything up on there. So you really have to look at your property and work out, well, what are going to be my operational parts of this land? What are the parts that I want to save? What are the parts that are going to keep coming back and bite me on the bum? And in this case, you've got flooding, not from coming onto the property. This is flooding coming back up from the river. So this is quite low lying, and you can see right at the back there, there's some old yabby farms and yabby ponds. And a lot of that land is not used, it's left because it inundates quite frequently. And the question that came about this was, well, Steve, I really struggle to find exactly where my fences are because, again, it's not that hilly. Once the grass grows, you can't see the fence, lose sight of the little lambs, and it becomes a little bit problematic. And when you get a very wet period, it's very hard to make your way down to certain parts of your property without digging it all up in the four-wheel drive or the tractor or whatever. So what we did is we did the whole drone survey, and then I just went down and panned into the orthomosaic, the high-resolution image that you can get, and you can just trace out exactly where the fence lines were. And that's the fence lines that she actually has in play at the moment. This is Kate down at Bulladella, and it confirmed something that a very simple mud map that she had from the previous owner, and sort of started joining up all the dots. So it allowed them to go back out and target different fences, different paddocks, look at the state of those at the time, and decide what they were going to do at different times. This is Kate's, yeah. Yep. Very flat, and as I said, the water actually runs, from, left to right from the bottom corner and sort of runs right through that property, but all that water through all that wetland and salt marsh floods up from the river. So it's really water coming up rather than flood water moving through, which is, again, a different issue to have on your farm. Now, if we move on to this project, this is the one I was talking about. So this was funded by MEMS, which is the Marine Estate Management Strategy. They're state funding to the tune of $50-odd million. They're looking at all estuaries and coastal waterways up and down New South Wales coast. At the time, these 8 properties got together with council and with Hunter Local Land Services, and obviously a lot of these, I think all of them are land care members as well. And the idea there was to do exactly what I've just described then. Do the drone survey, find out what we've got. Council, fisheries and everyone else said, well, look, we really want to protect these areas. Now, coming back to if you own your land, so this is Greg Howe's property, and I've missed a little bit, they had some corrupted images. But the idea for Greg, what was proposed is, well, that's your farm, but instead of allowing your cattle to go, livestock move all the way through it, we want to fence off all of this. So you can just use that little bit. As a farmer, you're sort of saying, shit, what's going on there? You're just taking 70% of my land off me. But it wasn't exactly that way. Same here with Rod's place. A lot of them have significant amount of wetland areas all throughout this. And this is the Branch Creek and this is the Branch River. So to convince a farmer to spend hundreds of thousands of dollars on fencing to fence off anything up to 70% of your land to save the ducks and the riparian zones and that sort of thing is quite a big ask. So the frame it around was water quality. Now down in the Branch Estuary they have quite poor water quality. There's a report card that comes out every year, for everywhere up and down the New South Wales coast. And it always gets a C. It's always one of the poorest water quality areas. But where it sits in terms of the Greater Kirill catchment, the pollution doesn't come from these adjacent properties right next to these creeks and rivers. It actually comes from further up in the catchment. So what we can demonstrate on these properties is that the water quality has improved on site because they've fenced off the dams. The water quality in the estuary still has its ups and downs based on rainfall. But anyway, I won't go into the detail of that project. It's really about the drone. So as you can see there's lots of sensitive areas, and they're the property boundaries. So when it comes to farm planning, this is a perfect example. So this is done through QGIS, that mapping program I was telling you about. So the parts in green are the bits that fisheries and Hunter Local Land Service would like to see protected and have livestock excluded from those areas. The crosshatch areas are the grazing areas, which become the new, okay, well, if I'm going to do something here, this is where I'm going to do it. And once you've got that all in play, you then have to ask yourself, well, how do I go about fencing all that off? And all those little blue lines are all the new fencing that was put in to the cost of just over $300,000. So that's on all the properties. So $300,000 is a hell of a lot of money. And how do you justify, the success? Or because as I said, if you're looking at salt marsh and mangroves, the questions that are asked by fisheries and the vegetation people is, well, are the mangroves expanding or contracting? Are the salt marshes expanding or contracting? We've already demonstrated that with all this rainfall, the whole estuary becomes freshwater at different times during the year, particularly over the spring-summer break. That has an impact on the ecology. It has an impact on the fish and crabs and everything that comes in there. These areas, whilst cows and everything still make pockmarks and chew it all up, is probably not contributing to the prawns and nursery and all the things that warm and fuzzy stuff that we want to see happening. But as a farmer, you know, 10, 20, 30-year timelines just aren't on the horizon when it comes to spending this amount of money. So the whole process over the last, well, this has been like 8 years, and then we started this on the ground probably about 3 years ago, and then the monitoring and all of this sort of work to show how well it's worked is probably the next step of what we're trying to do. And the drone has been an important part of it, because the reason I'm using these sites is because I've done several, at least 2 of these, so I can show you different points. So here's the first one. So when I showed you Greg's property with where he, had the big chunk of his land, which was all, well, he has a lot of mixed forest in that patch. But right along the edge here is the salt marsh and the mangroves. Now, obviously the green bits you can see are mangrove, and you can see all the tracks from the cattle as they used to come down into this area. And these little gold diamonds are just points for eye reference, for comparison. So basically they come in, they walk around, they particularly go around the rims of this because they're eating the salt bush, they like the minerals and things, they'll have a bit of mud, they'll keep going around the rims, and you can see this what they cause, it's really like, becomes like a fire break. It gets compacted and nothing will establish in that area. And if you keep letting the cows go down there, nothing's really connecting up. And you can see they break through the mangroves and go into different areas. But 12 months later, or 12 and a bit months later, the cattle being excluded from all this, and you can see that all these firebreak areas have started to grow back. The condition of this salt marsh is significantly better than what it was after the prior to the first survey, well, post the first survey. And this is the sort of example that we can see across all of these properties. So when Greg looks at that, he cracks a beer and does a little jig thinking this is great. He loves seeing this because this is exactly what we wanted to happen. The bigger picture things when it comes to coastal and estuary management are sea level rise, development, quarries to subdivisions and a whole heap of other things. And they'll always be part of the challenge and development of what we're going to do. So things like sea level rise, if you look at the literature, they say, well, if, water in the Port Stephens rises, 0.4 metres and we get a flood event, a lot of these areas will become inundated with salt water. Now, the salt marsh will love that. It'll hold its ground. But if we get more rain like we've had over the last couple of years, and most of the spring, summer periods, these Branch River and Branch Creek have been freshwater, so 50,000 microsiemens per centimetre for salt water, 300 for drinking water out of your tap. These range between 50 and maybe 1,500 for 6 months of the year. Now, the question I asked was, well, what does that... I know the salt marsh don't like too much fresh water because that's not where they hang out. So it's anticipated that the mangroves, under that sort of event, will move further back and take over the salt marsh area. Okay? So I won't delve into all of these sorts of things, but that's the sort of stuff that we're looking at on the big picture in these estuaries. Yeah. I think Greg's got about, well, if I go back to this one, I think it works out, I think Rod's got about 70 or 80. I think Greg's got between 30 and 40. Lower numbers here, Rick has half a dozen longhorn ones and 20 goats. Brian has a fair few. I'm not sure about his numbers. And and Terry's, the two Terrys, they don't have, again, they're not large numbers. So we're not talking hundreds of head. No. Well, what part of the design of this was new watering points. So following on from where your dam is, you can set up a solar pump and pump your water up to the top of the hill and either feed it back in for land hydration, or you can feed it off to water points for your livestock so they're not continually going down and hacking up the riparian zones of the drainage lines as well. Now I was talking about the NDVI and how important that can be, or what we can use it for. So these are just a series of filters that we can get from the images that we have with our drone. And when I was looking at these wetland areas, there was a couple of things that jumped out at me. I thought, I'm not too much of a long bow, but the mangroves come up really bright green, and you can see that on the right-hand picture. And the photo on the bottom left sort of gives you an idea of what the mangroves look like. The blue square is salt marsh, and in the NDVI it comes up as a dark orange, like a rust colour. The casuarinas, which are in the red square, is a sort of mixture in between. It's a much lighter. And then when you marry that up with the orthomosaic image, you can ground truth and confirm what you're looking at if you know what you're looking at. So if you can go out there and know they're my casuarinas, there's my salt marsh, and you have an idea, you can look at data like that and think, well, okay, and the next step for all of this is to take like that shot on the right and put it through image processing software where it'll take, tell you what percentage of that image is green mangrove or salt marsh or anything, but that's even a bit fancy for me at this stage.
Can I just ask, with that right-hand one, the collected one, with green areas, that's presumably pasture.
Yep.
Is that indicative of the density of the pasture, the darkness of the green?
It'll probably be more of the height of the grass as well. Like it's, it does come a bit tricky because if it was one of those cloudy days where the cloud comes across and blocks the sun halfway through your drone run, it sort of sends the shadow across, and we've noticed, particularly in some of the bigger properties that we've done, that's, it sort of makes it a bit hazy. No, this is just it's a light filter. So it's near infrared, blue,
So
green.
it's probably actually just picking up literally the density of the green and the half.
That's right, yeah.
So it's probably actually telling you what your nitrogen efficiency.
Well, but if you start changing the filters around, I can turn all that green into that rust orange.
Would it be right to
You know.
say, Steve,
Mm.
that the way it's picking up, it's kind of, it amplifies certain the effect of certain wavelengths, so there's more quantities,
Yep.
the more chlorophyll activity that's being needed you've got.
Well, look, that's why we need the multispectral camera, because we need that high resolution. Like with this sort of, we obviously take the drone flies and takes the photo straight down, but if you did it at 9 o'clock, 11 o'clock, 2 o'clock, a different angle of the sun, I'd say that you'll see different things because of that, particularly with shadows. Shadows all turn into rust brown type of, even though it's on green grass. So there's a lot of things which I'm still not that. Whereas with the multispectral camera, it splits all of those up. So you're looking at many, many more wavelengths. I'm also been experimenting with the thermal camera, which is pretty much your infrared, and I'm looking at soil moisture in pasture. So the idea there, you'll get similar type of density changes, but it'll be based on temperature, and that is that if you've got more water in it, the chances are it's going to be cooler at the end of the day, rather than a dried out parched soil, if that makes sense. So my next experiment will be to measure soil temperature, for example. Well, this is what I'm saying. There's going to be all these things that we're going to have to be aware of. But we've got the soil moisture gear, we've got the thermal imaging gear, and we've got the soil temperature. So if I go out onto a playing field at the university, which is my test site at the moment, I can go out, take all my measurements, send up the drone, and then have a look to see if there's any correlation. And there seems to be some, but it needs a bit more working out. I think what we need to do is develop a multispectral library for the region with our veg types. And as I was saying to Tyrone, go up to his place and go over the forest, knowing that some are brush box, some are eucalypt, some are something else. And the other thing too is when all these things start going into flower, they start giving different signals again. So there's still a lot of work to do with the multispectral, but you can focus it down to the point, and that's why we're starting with simple grasses in the beginning. That I think there's a lot of benefit there, potentially down the track. But we just have to keep collecting the data and having a logical, robust, scientific way of what it all means.
It's great. It wasn't a quick answer, we just come up with lots of good, useful questions.
Form it into a research.
So do you think in the future, as more capability becomes available from drone deploys, you'll be able to run the same data through the new capability, or will you have to redeploy?
No, you can run the same data. Yeah, because it's already there. Once the new apps come into Drone Deploy, it's just... now, Drone Deploy is just one of many different platforms out there that you can use. I mean, with the drone, the Phantom that we have, we fly under a DJI app, and within that app, you can set up your own flight paths, and it's similar to like we do in Drone Deploy, and fly it with the app. You don't need Drone Deploy. But once you've got the images, that's where you've got to upload them into another program. Because as they fly, it gets this overlap. So it's 75% overlap of each image in front and 65% on the side. And that has some implications on a relatively windy day when you've got tall trees doing this, flying backwards. And I'll talk about that a little bit later as well. Here was the final map that we set up for all the 8 properties. And as you can see, like going back to the conversation on grazing, you can see that these are all the grazing areas here. Yep. But the mangroves are also green as well, and they're not pasture. So I just focus on the wetland in this case. And you can take this map into that QGIS, and again, you start creating the layers. So I just went in and I just traced around all the green to give me my mangroves, traced around the salt marsh areas in light blue, and that's samphire, sand couch sort of thing. The purple is the grey mangrove open forest, and the yellowy bits are more of a vegetation complex where there's lots of different types of things in there. But now that they've been mapped, we can see if they, get bigger or smaller or change vegetation types with those changes in everything from water level, water temperature, water fresh to marine, and these sorts of things. So after I sent off, I got some great feedback from everyone. No one sort of said, look, this was a waste of time. Everyone was quite excited with once they got what they got. And again, I tried to work it so that it would become very easy. So you get your .kmz files, open up in Google Earth. The resolution that we get from the orthomosaic GeoTIFF image, they're the ones that are, several gigabytes. More than happy to supply them, and they will just open up in Windows Viewer, in your Windows photo editor sort of thing, and you'll be able to pan in and out for those. And with Tyrone's example, he was very happy that he found a brush box stand that he didn't know he had on his property. And that was obviously always great to find a new discovery. But what we'll do is we'll head off to drone deploy now. And we can start off here. Now this is Fred's place, Carol's and Craig's. Okay. So what we did, even though these are several properties, we did them at all at the same time because it just made sense.
So you can click on the photo where it says building is about where we're sitting, and if you look out those windows, that's kind of looking down in the side, sort of looking to the south.
Yeah, we're just over here. But it's a shame because on this screen it's not going to come up very well. But the resolution that you get through these is actually quite good. So as you start panning in, and I always good. It's like where's Waldo? You'll always find me somewhere in the map, and it'll be the silver Challenger, and and there's me there. So that's pretty good resolution. And when you're, counting cows or doing something like that.
That's our high-tech water drops.
That's, yeah.
It looks like an exclusive design.
So when we're in this, we can go into, the plant health, which, as I said before. So that gives you that map. And then if you go into, this gives you the different filters. So that's currently near infrared, red and green. The red, green, near infrared pretty much flips it all around, because you're just changing the order of the filters. Don't ask me too many questions about, well, what does all that mean? Because I don't really know what it all means, but there's a series of different algorithms that you can use, and these are, again, I'm not sure of the difference between them. It could be, it is an algorithm that runs this.
Are there any recognised databases, for example, CSIROs or something?
They,
Use interpretive real on it? Because I feel like that must have billions worth of data.
Well, a lot of it's satellite stuff, and they do use the thermal imaging, as you said, for soil moisture. They use multi-spec for different vegetation, you know, around the world. And
So, yes, so they use it, but do they have some recognised databases for identification of vegetation types?
no, no, no.
So much of it, we found is, you walk around, if you go through it, it's just a real snapshot in time, on a very dynamic.
Just go around and look, say, okay, that depended, and I've done a look, and it was probably what,
Yeah.
last year was completely
Yeah, whereas if you came back 6 months later, you know, the colours might have shifted, but you still get, on that day, you get the repeatability.
So this is the KNZ file you sent out to us.
No, this is drone deploy. So I export out of this drone deploy, and then I import it into Google Earth, then I export it out as a .kmz, and that's what you get.
So you're now working live, and this is, when you're preparing everything and analysing it, this is the view that you've got of the toolbox.
Yep.
So this is the flight code.
Yep. Well, you can go into. Well, I'm in Explore at the moment, but yeah, we can go into the fly side of things. But I'll just go into. So basically, that shot there is the elevation, but including all the trees. So that's why the trees look bigger. But you can remove that just to give you the terrain. So that's effectively what it looks like over here up on top of the hill. So you've got the hill at the top. You've got a couple of little drainage lines going down here, a couple down through here, and then obviously off the back side of that as well. And if you want to export something, you can, a PDF map, the GeoTIFF map is, this is what I take, and so again I go in and change it to GDA 94, MGA zone 56, which is just what we do around this neck of the woods. So yeah, look, there's so many ways of digital terrain model, elevation, point cloud. There are so many, but if we...
So this is where the raw data is stored, effectively?
Yeah. Yep.
Is this a tool that we will be able to access?
So this was actually quite a big property. We'll go into fly mode here. So this was 166 hectares. Takes 5 batteries. Flew at 115 metres, and so this was one of the biggest properties, which was fine because it, you know, to be flying the drone for that, it's a good example of one where I did have a bit of cloud on this day. And I'm not sure if you can see it, but it sort of looks a bit striated. You know, it looks like there's, you know, and that's just, as I said, because the cloud flew over at different times. But that doesn't affect your survey. It got me thinking about, well, let's look at the patterns during a growing season or a grazing season on a property. And young Matt Barry up at Stroud, we looked at his property, did the drone survey, got the drainage lines and everything done, did one soil test in a couple of paddocks because he had 2 soil types on his property, so we just limited it to one of each soil type. We did it from 0 to 20 centimetres. We did the full agricultural test, which gives you cation exchange capacity, pH, conductivity, and all the things which you would normally get as the soil consultant, and he'd say, oh, your phosphorus is down, you know, gypsum and chicken litter is the answer. And we always felt that that's probably not enough for the farmer who wants to get an idea of what's actually happening throughout a growing season, and this applies to trees as well. Because, you know, I'm a great fan of David Attenborough, and he talks about fungi network, or the scientists he talks to, will actually communicate with each other in a forest. And they can send out electrical signals and chemical signals to, support each other, and other trees can send out toxins to say, no, you stay on your side of the thing. And this is it's like a neural network underground. Now, the soil bacteria and fungi are the second largest carbon store on the planet, other than algae in the oceans. So just my simple soil mind says, well, geez, if we've got more bugs in the soil, we must be having more carbon in the soil. So that's why we're measuring fungi and bacteria. Now, in Matt's property up at Stroud, the numbers are relatively low, around, say, 200, whereas 1,000 would be an excellent sort of number. And
Number in the bacterial count.
yeah, and you can do a ratio as well. So in a disturbed mindscape where there's very few, you've got your pioneering grasses come in, and you'll have a fungi ratio of 0.001 bit of fungi to 1 bacteria. When you start moving up to complex forests, it's up in the thousands of fungi per 1 bacteria. And there's a whole food chain, as we spoke about at my last soil conference, where we understand there's lots of fungi and bacteria. We don't know if they're happy together or they're at war at different times, under different conditions, under different crops, under different trees, or what have you. So again, it's another cutting-edge part of soil science, but to me, as a simple metric, if you've got lots of fungi and bacteria in your soil, I think you're heading in the right direction. And we're talking to Lee, and sugar uptakes and assimilation of nutrients into plants in the first place. We believe that the fungi and bacteria play the key role in transforming that into a... So up at Matt's place, we've taken, a bookend. So over 12 weeks, we took soil sample at a couple of spots, a soil sample at the same spot as we took before, and then I went up there and measured soil moisture and fungi and bacteria on 5 occasions during that. So you could hopefully plot a pattern to see what was happening. The land had a few cows on it, an old grey mare, and they didn't plough anything, mulch it or do anything. So it's a non-active, untouched, and nothing happened. The range didn't do much. Whereas we'll be looking at a dairy farm next week over the next coming months, where they've applied chicken litter, turkey litter as different amendments, and we'll see what those numbers mean. One hypothesis is that you put on the chicken litter and you actually might kill off a whole range of your fungi and bacteria. You might burn them out or something like that. We don't know. Anyway, lots of questions. You end up with more questions that end up.
But then potentially, Steve, is that retaining a career and therefore supporting the water quality project?
Yes.
So can that research be supported by MEMS?
Look, I think it can. I think it can. There's lots of other. In fact, your property was in River Road was put up as because you're just north of that whole little catchment. You're actually on the other side of the hill, but you feed down into, Hell's Gate and Pumpkin Point down there. So I think you'd be ideal to go in there if you had, say, well, we want to fence off this bit. I'm sure, they can get some funding to do that, and then we can put you on the list and do the drone stuff and, be part of that. Because Rod calls it the G8 because there's 8 properties. He wants a G20.